Hello guys, welcome back to the channel. So in today's tutorial, we're going to go ahead and use computer vision to build a simple biometric authentication system. So what this system is going to be, basically, whenever you show point a picture to your webcam, to be able to detect the picture and then check in the file system if the user with that name or a picture that with that the specific identity already exists, and if it exists, it will update a registry which is going to be a CSV file, basically, to mark a person to be present. So it can be used like in a school system or in a workplace whereby you want to create a registration system whereby people can automatically get ticked as present whenever they come at work, or whenever they show their ID or a picture to the camera. So that's what you're simply going to build. So let's get started. So the first thing we need to install is we need to go ahead and actually set up our environment to install a couple of libraries. And before we do that, guys, if you're new to the channel, please kindly consider subscribing, liking this video, hitting the thumbs up, and sharing this video with anyone who you might think will be interested in this video. So kindly consider subscribing. Go ahead, hit the subscribe button and hit the notification bell so that you guys can know get updated whenever I load future videos on computer vision, web development, and data science. Okay, thanks for watching. Thanks for doing that for me. Let's continue. So the first thing that we'll need to do is to install the libraries that we need to do. We need to install. So I have my virtual environment already activated, so I have created a virtual environment. If you don't want a virtual environment, then feel free to skip that step. So the first you're going to do, you're going to pip install. You're going to install OpenCV -Python. So this OpenCV -Python, you're going to use OpenCV for this is an image processing library in Python, and then for doing machine learning stuff. We'll also need to install Numpy, and just run that. I've already installed all this prior to making this video, so you always see the requirements are already satisfied. Also, you need to do pip install CMake. So you need to also install CMake. I've already gone ahead and also already installed CMake. After installing CMake, you have to pip install. You have to install dlib. So dlib. Sorry, let's do pip install dlib, just like that. Install dlib as well. And once you have that installed, also now we need to install one more library called face pip install face. Let me just say face -recognition, just like that. This is a library in Python, so go ahead and also install that library. I already have all this library installed to save time, because they can take quite some time to get installed, especially when installing dlib. You can take quite some time to get installed. So if you want, even if you want to install, read about these libraries, you can just go to Google and then search for pypy.org, and then in here you can type in the individual library. You can type in CMake and you get back CMake. You can install the first one. You can also get face recognition. You can also search for this library, and then you can click on the first one and then install the very first one. So we're going to be using face recognition for this project. So you can see face recognition. Here is the documentation on PyPy. You can also go to official documentation and read about what face recognition is. So it's just a Python library that is used to do used to recognize human faces using machine learning, specifically support vector machines. Okay. So in this what we're going to do. So let's write a simple program to detect human faces. So I'm just opening up my Visual Studio Code. So in my Visual Studio Code, I have a file called, let me just show you. I have a file here called attendance system, and I'm in that file. And inside of that file, I have a folder called resources, where I'm going to keep all my images. So if I go on resources, you can see I have this couple of images in there: Bill Gates, Elon Musk, then Elon Musk again, another picture of Elon Musk, and I also have a picture of Jay-Z. So I'm going to be using these pictures, these images, to train a model and to create a registration system for these individuals that are within the resources folder. Okay, so once you have that, I'm going to call it basics.py. Okay, so in here we're going to go ahead and import CV2. Once you have CV2 imported, I'm just going to go ahead and load a couple of images and display those images. Okay, so I'm going to say I'm going to call this image, simply call this image as Elon Musk. So I'm going to say Elon _ Musk. I'm going to load an image of Elon Musk, basically. So I'm going to say cv2.imread, just specify the part of that file that you want to read. And then the file I want to read is going to be in resources, my resources folder. So resources / and then that image, and the image I want to read is just called Elon Musk. Okay, so just like just close this off. Just here is going to be it's just an image of Elon Musk _ Elon Musk. just like this, .jpg, just like that. So I also want to read another image of Elon Musk called Elon Musk underscore test. So I'm going to say test underscore image, and this is going to be CV image. It's going to be cv2 cv2 .im read. So you're going to read this how you read images in OpenCV. You're going to specify the part that image. So you're going to say resource / resources / you call it Elon underscore Musk underscore test.jpg. So once I have read those images, let's go ahead and actually display those images to the end user. So we're going to the cv2.im show, which you're going to show an image. You're going to give the title of that window. You're going to call it Elon, just like this, Elon Musk. And then I'm going to specify the image that I want to display, which is going to be Elon Musk, just like that. So I'm going to also display the second one. It's going to be cv2 .im show, and you're going to specify, you're going to say test image, just like this, and you specify the image that you want to display, which is going to be test underscore image, just like this. So once we have this already done, we have just read the image, and now we want to create a window to display the image. So you have to wait for a couple of seconds, or this will be too fast that you can be able to see. So you're going to say cv2 wait key, and then you're going to wait for let's say 7 seconds. So this is going to be 7,000 milliseconds, which is 7 seconds. So we're going to wait for 7 seconds. After that, the windows will get closed. So we have just read the image, and then you're displaying the image. You're creating the windows to display the image, and the title of the window is Elon Musk, and displays Elon Musk image. This one, the title of the window is image, a test image, and it displays the test image. And you're going to wait for 7 seconds. 7 seconds after that, that image will get closed. So once we have that, I can just go ahead and do an run that. So I can say Python 3 and then basic, just like that, and run this basics.py. So this is going to open a window to display to us those two individual images. So we can see I have those two images loaded right here. So you can see what the one for Elon Musk, and the other, this also the test image and the actual image. So if I run this again, you're supposed to see those two pictures. So there's Elon Musk image, which is this one. The title of the window is Elon Musk, and then you have the test image, which is this one. Also has another picture of Elon Musk, and it closes after 7 seconds. So that's how you can read and display an image using OpenCV. Now what I want to do right now that I am able to read the images and display to the user, what I want to do right now is actually get to find the location of the different face within an image. So let me just run the program and explain to you what I'm trying to do. So we have this image right here, right? So this image is maybe forms this part. So we want to draw a box around this image, right? The face of that image. So for us to be able to draw a box, we need to get some coordinates, right? A box has four points, right? So we need to get the points of each vertex forming that box. That's what I'm trying to get. And to get this, you're going to be using the face recognition library that we just installed. So we're going to import import face underscore recognition, just like that. So once I have face recognition imported, I can just do face. I can say face underscore location. And face location, what I can simply do in here is display get the location of these different faces. So I'm going to say face underscore recognition dot face underscore locations. So make sure this is S locations and not location. So I'm going to pass in the Elon Musk image, and this is going to return to us an array. Now in this array, what I simply want to do is to get the very first element of the array, and this very first element of the array is a tuple that contains the data that points to the individual locations on an image. So I can simply, it's going to return to us a tuple that's going to have top, right, bottom, and left. So it's going to return to us the coordinates of the top, the right, the bottom, and the left. So we want to use these coordinates to plot something, to plot a box on that on the image. So you can use these individual coordinates, the top, the right, the bottom, and the left coordinates, to plot a box or a rectangle around the face that has been detected. So now make sure that I have to keep here index 0 because I want back this tuple and not the whole return of this function. So once I have that done, I can also copy the same code and paste it for the other, and I'm going to change this to be test image, and then test underscore image, and then this one is going to be test underscore face location. So once I have those two done, what I can simply do, go ahead and actually draw a rectangle around that face. So I can just go and do cv2.rectangle, and this is going to draw a rectangle. So you have to provide the image on which you want to draw a rectangle around. So I want to start with the Elon Musk image, and I have to specify the points. So I have to say the points. So I'm going to say face location, and I have to specify those points. So I'm going to say index 3, which is going to return to us index 3 is going to return to us the left, and then you're going to say face location, and then you're going to specify index 0, and then you're going to specify another tuple here. Is going to be face location. This is going to be index 1, and then you say face location again, and then specify this is going to be index 2. So once we have those set up, what I can simply go ahead and do is simply providing the color. So the color, these are RGB values, so I'm going to say BGR values, because OpenCV uses the BGR scheme, okay, instead of the RGB scheme. So I'm going to say 255, 255, and then comma 0. So once I have that done, I can specify the thickness of this rectangle, and I'm going to leave the thickness to be 3. So this is going to detect the locations of the face within the Elon Musk image and give us the coordinates, and using those coordinates you're going to draw a rectangle on that face, on that image rather. So let me just format this a bit, and format this a bit. Yeah, that's basically what I want done. So let me just go back into my terminal and try to run the program. So I'm going to simply run the program again, and let's see what we get this time. So this is going to return as the image with the coordinates drawn on it. So let me just scroll this one, so you can see the Elon Musk image has the coordinates drawn on it, which are the rectangles. So these are the individual points that we specified. Okay, this image will close after some time. So let's actually increase this to be instead of just 7 seconds, let's make it 10 seconds. Okay, so once we have that done, let's also repeat the same and draw for the other test image. So I'm going to copy this and then move down here and paste here. So down here I also want to draw the same image. So what I'm going to do here, I'm just going to change all of this to be test underscore image, and then here these are going to be the locations of this individual image. So I'm going to change this to be this value here. So change all of that, change it, and also change it here. So once I have that, if I run the code, I will see that all the images have the box rectangle around the human face. So if I run it again, we should get that. So you can see that both of them have the rectangle around the faces within that image. So great. Once that's done, what you can do right now is also now be able to recognize these faces. Like I have these two faces, right? If I bring back the image, I have these two faces. So how can I tell, or how certain I am that these images are the same? Because this is facial recognition. We want to be able to recognize that this is Elon Musk, and also in this image we also want to recognize that this is Elon Musk. So basically we want to compare these two images, right? So this is what you're going to do here. So to do that is very simple. So face recognition, the way this library face recognition works is that it uses a series of points on the image to do the image classification. So for this, it uses 128 individual points that uniquely identify each image, and uses those individual points to train a support vector machine that is used to recognize each individual image, right? So if you're new to machine learning and don't know what a support vector machine is, I have a whole tutorial on support vector machine and how to use it, so you can go and check out that video. So this face recognition library uses this 128 image individual points on the face that it collects to train a support vector machine that is used to do the classification. So let's go ahead and actually encode these images. So I'm going to say encoded Elon. So I'm going to say encoded Elon, and this is going to be face underscore recognition dot face underscore encodings, and then I'm going to go ahead and actually pass in the image. So I'm going to say Elon Musk image, and I want the first index of this. So I want index 0, so I'm going to pass in index 0 here, and you're going to repeat this for the other image as well. So I'm just going to copy that and paste it down here again. So this is going to be going to test we say encoded test, just like this. And now you're going to change the image here to be test underscore image, just like that. So now that we have all of this, we can go ahead and actually print this out. So I can just go ahead and print encoded test. So this is going to return to us the different 128 points on the image on the face that is used to provide as an input to a support vector machine that is used to done the classification to compare different faces. So to do facial comparison, now first we have the original image that you want to compare, and an image that is unknown, right, that you want to compare against to see how similar these faces are. So let's run this code again, and this should print out the first one, the 128 individual data points that are used by the support vector machine to make the classification. So you can see these are all the individual 128 points. So great. So these 128 points are the input to a support vector machine. So to be able to classify an object, let me just comment this out. To be able to classify an object, we take these encodings and see how similar they are on the support vector machine. So now that we have the encoded points, let's pass these encoded points to the support vector machine to do the classification. So we're going to say comparison underscore result, and this is going to be it's going to be a face recognition. So this will be face recognition. So face recognition, the face recognition dot compare underscore faces. So now you need to provide the first argument is a list. Now the list, this is going to be a list of all known images that you want to compare against. So this is going to be a list of known images. In this case, you have only one known image, which is going to be encoded Elon, right? And then we want to compare this list against the encoded test, right? Encoded test. So I want to compare everything inside of this list with this test image that we got, and if it reaches a certain threshold, it returns to us a boolean whether the images are the same or they are not the same. So I'm going to go ahead and print comparison result. So this is going to print a boolean, either a true or a false, depending on whether the images are the same or the different individual images. So I'm just going ahead, clear this terminal and run this again. So you can see it returned to us true because these two pictures contains of Elon Musk. So the comparison returns true, and that shows that the images are the same. Great. All the images consist of the same individual person. So you can also go ahead. Let's change this to another image. Let me just use Bill Gates image. So I'm going to say Bill underscore Gates, just like that. Now if I run this again, what do you think the output is going to be? Because Bill Gates does not have the same facial features as Elon Musk, so the answer should be false, and you can see it is false. So if I bring this right here, you can see it's false because Bill Gates and Elon Musk are two different people, so the comparison returns to us false. Great. So now that we have that, let me just return back the test image. Now this is being done by the face recognition library. It has a certain threshold that it uses. What if you want to get a value that you can use to set a threshold yourself? So what you can simply do is you can say face underscore distances is equals to face recognition. So that's a face underscore recognition dot face underscore distances face distance, just like this. And in here you're providing a list of the known images, which is just going to be encoded Elon Musk, and the encoded test, just like this. So this is going to return to us a distance of these images. So the more closer the more smaller the distance is, the more likely their faces are belonging to the same person. Okay. And the more the bigger this value is, the less the images are similar. So that's the concept. So you can also use that to set a threshold, and then you can write an if the condition is bigger than a certain threshold, then you can approve or not. So you can see these two images, the distance is just 42, so they are quite similar images. So now let me just take this back to the Bill Gates. So you can say Bill underscore Gates. Now if I run the one for Bill Gates, just run this again, and let's see if the images are the same or they're not the same. So let's run. You can see the difference is 66, so the difference is quite huge. So you can see that these two images are completely of different people. That's why the difference image distance is just 66. So great. So now you're being able to compare different images. So now we're going to write a project that is going to turn on the web camera, identify an image, and then be able to determine if the image is within our resources. If it's within our resources, then we're going to register, put that person inside of a CSV file, and which is going to be the attendance file basically. So let's just go ahead and say attendance. So I have created a file called attendance.sys.py. So in here I'm going to go ahead and import the things that we are just using from here. So I'm going to go ahead and import all of this. So I'm going to go copy this and then paste them here. This actually is not there. Let's can remove it if you want. Visual Studio Code just imported that automatically. So what I'm going to do, I'm going to create a capture object. I'm going to use cv2.video capture, and I'm going to put in 2 because I have an external web camera, and that's what I'm going to be using. But in your case, you have to put this to be 0, or you put this to be 0 to use the web camera of your computer. If in case you have a laptop, but you should specify the ID of your camera, the camera that you want to use. Okay, and then you say while true. So in this case, most people 0 will just work for you, so you just keep 0 and try it out. If it doesn't, just regularly change the numbers and do some Google research. I think you can get the ID of your camera, but start with 0, and I'm sure 0 will work for you. In my case, 0 works, but I'm trying to use an external camera because I want to demonstrate this to you guys. That's why I'm using an external webcam. Okay, that's why I'm putting here 2. So now I'm going to get success image, and this is going to be cap.read, just like that. So this is going to read the image, it's going to read the webcam, and it's going to return to us success in case it has been able to read the webcam, and false in case it failed to read the webcam. So we're going to check if not success, then you want to break. Else, what we're going to do, we're going to say cv2.imshow, just like there we did. We're going to say image, and then we're going to display that image that we got from the webcam, which is stored in a variable called image right here. And then I want to do cv2.wait key. I want to wait 1 millisecond, and I go to another frame of that capture of that video stream. So later, if I break out of the loop, I want to do cap.release to release the resource, just like that. So now this should now show us a video stream. So now I'm just going to point my camera to my laptop here, and then I'm going to go ahead and actually run the code. So I'm going to go ahead and run this is going to be let me change. This is going to be attendance system. So I'm just going to run that again, and I'm going to show my camera, point my camera to the to my screen, and this should now open up, and you can see my screen right there. So this is my webcam right there. Okay, so I'm just going to go ahead and quit this for now. So great, that works, and you're able to capture video from our camera. So now that's working. What I want to do right now is actually get the image, right? We're going to repeat the same process here. So if we get for each of this image that we'll get, what we want to do first is to find the location of that image, and then we want to encode that image to compare with the existing images that you already have. Okay, so the first we're going to do is to find the location of that image. Okay, so let's go ahead and actually do that. So let's go here, and then we can simply say the following. So here you can say face, you say test, let's say test underscore face underscore location is going to be face underscore recognition dot face underscore locations, and then we pass in the image that you want, and the image is stored in this variable called image from the webcam. Okay, so we're going to get the location of that face. So what we're going to do, we're going to say test underscore encoded is going to be face underscore recognition dot face underscore encodings, and then you're going to pass in that image. You're going to pass in the image that we just got, and then we don't want to encode the whole image, right? We just want to encode the section where the image the face is located. So we're going to say test face underscore location. So great. Once we have that, what we're simply going to do is run a for loop, and what the for loop is simply going to do is going to compare the image that you're going to get, the image that you got from the webcam, with the images that are going to be here. So let's write a function that can actually encode these images from here. But for now, let's just write the for loop before we go to that. So I'm going to say for encoded underscore faces comma location in, I'm going to use a zip, and then I'm going to say test underscore encoded, and I'm going to say test underscore face location. Okay, so we're going to get many faces here, so you can even say faces. Okay, faces and then faces. So it's going to return to us more than one face. That's why I'm using faces if you want. And then here, going to simply what we're simply going to do in here, you're going to match those faces. So we're going to say match matches, and this is going to be face underscore recognition dot compare faces, like the way we did compare underscore faces. And then you need to pass in here a list of the known faces. The known faces are going to be the ones from our file here called resources. We're going to compare this against the one that you just got from the test camera, which is stored in test encoded. So we're going to say test encoded, and then you're going to access the 0th element. So great. Now we need to write a function that to encode all of these images for us. So let's go up here and then write it here. So you're just going to say here, you're simply going to say we're going to call it maybe get def face encodings, just like that. And here what we're going to take an image underscore list, just like that, image list. What we're simply going to do here, we're going to say encoding. We're going to create a list here called encoding encoding underscore list. So encoding list is the list in which you're going to store all our faces after they have get encoded. So we're going to say for image in image underscore list, just like that. What I want to do is I want to do encoding. I want to say encoding encoding is going to be face underscore recognition dot face underscore encodings, just like that. And I need to provide in my image here, so I'm going to say image, just like that, and I'm going to get the 0th index. And then I'm going to now add this to my encoding list. So I'm going to say encoding list dot append, and I'm going to go ahead and append encoding, just like that. So I'm going to go ahead and loop through all the images from this from the image list that I'm going to pass, encode all of them and append it into this list. And then finally I want to go ahead and return that encoding list, just like that. Great. So now what is this my image that you're going to pass in? So let me go ahead and try to call this function. So I'm going to say let me just say non as encoding underscore non-encoding underscore list, and this is going to be going to say face encoding. So I'm going to say face encoding. So I'm going to call this now. I need to pass in something here. So I'm going to pass in image list. So how am I going to get the list of all those images? So now we're going to go ahead and load those images in there. So I'm going to say path, and you're going to provide the path to our image. We're going to be resources, right, which is our folder called resources. And then you're going to have a folder called images, an array called images, and in there we're going to have a person's name as well. We're going to have person names as well, but we'll come back to this just in a second. So I'm going to say image underscore file underscore names is going to be os, let's just call it image underscore files. It's going to be os dot list the, and I'm going to provide it the path. So we're going to list all the folders inside of path. So let's go ahead and import os. So import os. So we're going to list all the images, and we're going to store it in here. So what you're going to do is that you're going to go ahead and now open all those images as we did. So in here, like, let me just show you the basics. In here we open those images using OpenCV, right? Now we're going to do the same part for all the images in here. So what you're simply going to do, let's say for image underscore file in image underscore files. We're going to now in there, we're going to create an image, and image is going to be cv2.im read, and then you're going to provide in the path to that image. So we're going to say we're going to use an f string. We're going to say path. This is going to be a variable that we define, a constant. So it's going to be path and then / the image name. So we're going to say image underscore file, right? Image file. And this is going to read all the files from that directory, and then read all of them by using image by using OpenCV. So we need a variable a list to store them in. So I'm going to say images, and the images is going to be a list. Okay. So down here I'm going to say images dot append, and then I'm going to append my image inside there. Great. So now that I have that appended, now I want to also get the names of these individual people. So because we're going to be using those names to update our register, so I'm going to say persons underscore names is going to be just an empty list. So we're going to now we're going to go ahead and split this file based on the full stop. So we're going to say person underscore name is going to be file image underscore file dot split, and I'm going to split basing on the full stop. So I'm going to split this basing on the full stop, and I'm going to get the first index of that list, which is going to be for example, let me just show what I'm trying to say. So I have Elon Musk here dot jpg, right? So if I split it, what I'm going to get a list of Elon and a list of jpg. So what I want, the first element, which is going to be the name of Elon Musk, which are going to be the name of these individual folders. So I'm going to split it that way, and I'm going to simply go ahead and say person's name dot append, and I'm going to append person name. So person name, just like that. Person underscore name, just like that. So I'm going to append person name to my person's names list. So now I can go ahead. It's giving me an error here, so it's gonna be image files. Let me just change that to be files. Okay, so once that we have that, now we can go ahead and call this function. So now we have the directory of all those images. Okay, we have the directory, and we have read them into a CSV file. So now we're going to pass in the file name in here. So we're going to pass in the list that in which we have stored those images. We have stored them in a list called images. So now we're going to simply go ahead here and pass in images. So if it goes for each individual image, is going to find the encoding and then append it to the encoding list, and then later we're going to return the encoding list, and that's going to be stored in this variable called non-encodings list. Okay, so great. So now that we have that, I'm going to now pass the non-encoding list, just like we did in the basic, right, where we pass the encoding of Elon Musk image inside of a list. But this is going to this is already a list. It's already a list which is being returned and stored in here, so we're just going to pass it in here. So for we're going to look through that, and for what you're simply going to do is we're going to find the matches, and when we get the match, we're going to match each individual image inside of our folder here with the current image that we got from the webcam. So once we have that, I'm going to check the face underscore distances. So I'm going to say face distances, and this is going to be face underscore recognition dot face underscore distance. It's going to return me the face distance. So I'm going to pass in non-face encodings, and then I'm going to pass in the test encoding. I'm going to get the 0th index. So let me just minimize this for now, close this down for now, so you guys can see all of the code. So once we have that down, I'm going to go ahead and I can actually print the face underscore distances if I want. So let's just go ahead and actually print it and see what we get. So I'm going to in here, and I'm going to simply go in here and simply run my code. Before I do that, I have a Google Chrome tab open here, which shows the different faces of Elon Musk. So let's run the code and see how our program does in comparing those images. So I have my webcam here. I'm just going to hold it in my hand and then wait for that to load. So you can see there. So I'm just going to move this move to the webcam here and then show the images right here. So let's see what we get. We can see we are getting those face encoded. So you can actually detect those values, and it's giving the values here. So you can see those values right there. So if I bring this, you can see it's pointing. Now it's difficult to see, but I'll show you more about this, so don't worry. So you can actually see it has a great very high distance here of 90%, which shows that completely is very far. Okay, let's just exit this, and then let's go back into our images right here. So you can see this this individual these values here. Let me just bring these values here are actually the values for each of those individual images. So in here we have the individual images. Let me just bring back this. We have this 1, 2, 3, and 4 images. So for those 4 images, you have 1, 2, 3, and 4 are the distances. So you can see this, the shorter distance is the one which has the Elon Musk image. So it's not this one, it's not this one, it's not this one, it's this one. So you can see consistently these values have been lower than the other one. So this is probably the image that it matches with. But let's go ahead, I'll show you this in a more better way to understand this. So I'm just going to comment this out for now, and then I'm going to go to match. I'm going to say match underscore index, and this is going to be np.argmax. So we're going to get the argument, the minimum value from these points here. You're going to get the minimum value from this array. Okay, so in the first array, the minimum value will be this one. That's what we're trying to get. We're trying to get its index. So we're going to pass in that value. So it's going to be we're going to say in your face underscore distances, just like that. And I need to go ahead and import Numpy that we have just installed. So I'm going to say import numpy as np, just like that. So once that's done, we can go ahead and actually check this. So just say let's say if matches, so matches, you're going to get the index of that. So we're going to say match index. So which index does it match it to? Okay, you're going to get the index of the minimum, and then from there you're going to pick that minimum from there. So you're going to check if it exists. So if that is true, you're going to get name, which is going to be person's names, and person's names, we want the index of match underscore index. You're going to get that name simply, and once we get that name, we can also use the location to get the location of that individual image. So you can see the location here. We got the location, so we're going to go ahead and actually use this location here. So you're going to say x1, so you're going to say y1, y2, no, x2 rather, that's x2, and then y2, and then x2 again, and this is going to be sorry, this is going to be x1. Okay, and this is going to be location, right? The location that is coming from this for loop right here, and the locations, we got the image location encodings from here. Okay, so now once we have that, we can simply go ahead and draw a rectangle around that image. So we're going to say a rectangle, just like we did in the basic part. You're going to pass in the image. You're going to say the image, and then you're going to it is an image from the webcam, and you're going to specify the name. Sorry, an error there. You're going to start x1 comma y1, and then you're going to go ahead and specify x2 comma y2, just like that. And then I can specify in here 255 comma 0 comma 0. These are just bgr values, and then I can specify the thickness of this rectangle to be 3. So great. Once I have this, I also want to put the name of, let's actually run this to see if it works, and then go in here, clear the terminal, and run this code. So I'm just going to go back to my browser and then those Elon Musk images, and let's see how our program performs. So you see it can detect Elon Musk on there on my webcam, even though the version the camera is actually not very good, but I hope you can see that it can actually read Elon Musk there. So if I move this, it can actually read Elon Musk. So if I show this properly, so you can see it actually reads Elon Musk. Not the best camera, but yeah, you can see it can detect Elon Musk's face right there. So great. It's actually having some problem detecting these other ones because the camera is not that good. Okay, so great. So now that we have that, it assumes that you can see that it works and it's able to detect Elon Musk. Now I want to write the name of Elon Musk where the box is. Okay, so sorry for those poor camera. My camera is not really good. Yeah, one way you can support my channel is kindly subscribing to the channel. I'll be able to buy better equipment. So I'm going to do cv2 dot I'm going to put text. So I'm going to put text on the image, and I'm going to specify the name, which is going to be the name that you obtain from the names list, which is just a string. And then I'm going to provide the origin. The origin is going to be x1. I'm going to say x1 plus maybe let's say plus 8, and then you can say y2 minus 6, just like that. And now we can go ahead and specify, okay, this is actually plus, so let me just put plus here, and then we can specify the font. So cv2 dot font, and you're going to use any font. I'm going to use any font. Font scale is going to be 1. The color is going to be 255 comma 0, just like the box, comma 0. And then I can specify the scaling, the thickness of that text, so I can use 2. So great. So now if I run this should now go and detect those Elon Musk images. So let me just run this and bring back, let's wait for the window to open up. So once the window has opened up, I'm going to go ahead and go to my browser and then bring this here. Let's see if it still identify this. So you can see it's Elon Musk and he's writing Elon Musk there. So the camera is a bit poor. Let me try to move the camera a bit closer. You can see it's detecting Elon Musk. It's a bit poor, so let me just try to move the camera a bit back. I don't have the best camera in the world, kindly consider subscribing to the YouTube channel so they can get some good equipment for these videos. So you can see, you can detect Elon Musk, but the camera is really not good. So yeah, so what I'm going to do, I'm going to pause this for now, and let me try to use my phone and see how if my phone gives a better image of Elon Musk. So I'm just going to go ahead, clear the terminal, and run this again. I'm now going to point my webcam to my phone, and let's see how that visual is. So I've just pointed my webcam to my phone. So here's my phone, and hopefully I hope you can detect Elon Musk's image right here. So let me just point it properly, so you can see, you can pick up Elon Musk, and you can see there's the Elon Musk, and there's Elon Musk's test. Let's take another image of Elon Musk, this image. Let's see how it does. So you can see, you can also detect, let's wait for it to detect it. It doesn't do really well because my camera is really not good. So let me just try to find another image of Elon Musk, and let's see how it does in detecting. So you can see, you can detect Elon Musk right there. So Elon Musk underscore test, which is one of the name of the folders, image folders that we have right there. So yeah, so guys, that's it. So now I'm just going to close this, and what I'm going to do right now, clear the terminal and then go back to VS Code. So what I want to do right now, that we can detect the user and be the image and the person inside of the image. Now let's write a program to update a certain CSV file that will take the person to be present. So I'm just going to create a CSV file. I'm going to say attendance.csv, just like that. So I'm going to go ahead and actually read that CSV file and update the CSV file in case we detect a person to be who is inside of the image file being inside of a given image that we show the webcam. So what I'm simply going to do, I'm going to go ahead and actually open a CSV. I'm going to write a function. We'll call this function def mark underscore attendance list, just like that, and I'm going to take in the name of the person. So I'm going to take in the name of a person who was detected in the image. So I'm going to say open, and I'm going to open the name of that image. So I'm going to say attendance .csv. I'm going to open that image. I'm going to already open it in an R+ mode. I'm going to open it as F. So I'm going to get all the current data inside of the list. So I'm going to get current. There's going to be just use lowercase current underscore current list, and this is going to be file f.read lines. It's going to read all those lines, okay? And then I'm going to get going to create a list. You're going to call it simply names. The names list, and it's going to be just an empty list for now. And what we're going to do, we're going to say for name in current list. Okay, what I'm simply going to do, I'm going to simply say entry. I'm going to say entry is going to be equals to, I'm going to split those lines. So I'm going to say names dot split and I'm going to split basing on a comma, because it's going to be a CSV file. Is going to consist of comma, so I'm going to split basing on that comma, and it's going to return to me a list, right? So what I want to do is I want to get the name from that list. So I'm going to say names dot append, and I'm going to simply pass in my entry, and I'm going to return the first index inside of that list. Okay, so once I have that done, what I'm going to do now is going to say if name it's going to say if name not in my names, right, my names list. If name not in names, what I'm going to do is I'm going to get current underscore time, and the current time is going to be date time dot dot now. Let's say, you can say now if you want. So you can also use UTC now if you want. So I'm going to go ahead from date time from, let me just say import date time, just like that. Just say import. So I'm going to say from date time import date time. So I'm going to say from date time import date time, and then here I'm saying date time dot now, and then you're simply going to now format that time to be the time that you want. So I'm going to say you can also format that time here. So you can say formatted underscore time. You can say formatted date or something, formatted date or time, whatever, formatted time is going to be current underscore time. Let's actually call this to be time, so it's going to be called current underscore time. So current time dot c is going to be strf time, and then you're going to pass in the time format that you want. So I want percentage sign, I want the hour, colon percent sign, I want the minute, and then colon percent sign, I want the second. So this is going to return to me that's the time format in that the time in that specific format. So once I have it, I can simply go say f dot I want to write my file, write lines. So I want to write lines, so I'm going to pass in the following. So I'm going to say f, use an f string. So I'm going to specify those lines. So I'm going to skip the first line, so I'm going to do backslash so I'm going to say backslash n, and then I'm going to go ahead and specify the name here. So I'm going to say name, and then I'm going to say the time. So it's going to be the time of that name. So let me not keep any space here. So it's going to be name, and then you can say the current time. So it's going to be formatted time, just like that. So for each of those names, if the name is not there, it's going to get the current time, and then it's going to get those names and update those individual that specific file. So that's basically it. So now we can call that right here. So in here it is going to call that function. So it's going to, we call it mark attendance list, and you're going to pass in the name. So it's going to go through and then check if that name is not present, because the name, we got the name from here using on the index, we got the name from here. So if that name is not present, it's going to update that. So before that I do that, I'm going to call it this name, and then I'm going to say time in, just like that. So once I have that, I can go ahead and close this. Now I'm going to go ahead and run my program again. So if I run this program, if I show Elon Musk to my webcam, then it should take Elon Musk to be present, right? So I'm going to go ahead, run my code again, and point my camera to the Elon Musk image I have on my phone. So we have an error there, unsplit. So let's go ahead on line 32. We have an error right there. So let's go there on line 32. Okay, so let me just actually call this to be another thing, because this name resonates with this one, right? So let's just call it for item. Let's just call it item. So you can say item, and then yeah. So for item in the current list, we're going to item dot split it. You're going to split it based on the comma. Yeah, so that's basically it. So let's try to run it again, and hopefully I didn't make any more errors. So I'm going to go ahead and actually point my phone to my webcam here, my webcam to my phone, and you can see Elon Musk test has been detected. So you can see that has been detected. So great. So even if I go and search for Bill Gates image, even Bill Gates will be detected. But for now, let's check if the registers are currently updated. So I'm just going to exit out of this and then go to my VS Code and then check this. You can see Elon Musk has been marked as present, and the time was this much, which is related with my time here. So great, it all works fine. So now let me just try to find another image of Bill Gates, and I can get a Bill Gates image and try it out and see how it works. So I'm going to images. I'm just googling something for now. So I'm just go ahead and try to find an Bill Gates image, and then I'm going to go ahead and actually run my program again and point my webcam on my phone where Bill Gates image is located, and let's see how it does. So let's see. I can't quite detect it. My camera is really not good. I just pulled up another image of Bill Gates, so you can see you can detect Bill Gates right there. So Bill Gates now will be ticked as present, so you can detect Bill Gates, but my camera is not the best. One way you can support the channel is kindly liking this video and subscribing to this channel. I'll be uploading more videos on machine learning. So one way you can support my channel is kindly consider subscribing. So you can see Bill Gates is there, but my camera is not the best, so it struggles to detect it, but most of the time it picks it up as Bill Gates, and it's going to mark Bill Gates as present. So great. So now that we have that set up, let's check if Bill Gates has been marked as present, and you can see we have Bill Gates right there. So even if you pull up Jay-Z image and try to find attendance for Jay-Z image, it will also take Jay-Z as present. So you can also provide in actually a video file. So you can just change, if you want to put in a video file, you just have to change this to be the path to that video file and to detect all the images instead of that video and take them as present or absent. So yeah, so guys, that's all for this tutorial. So you can also go ahead and actually open this up. Let me just you can actually open this up if you want in your Excel or whatever, and you can actually see those in a better format than this. So yeah guys, that's all for this tutorial. If you enjoyed this so far, give it a thumbs up and subscribe the YouTube channel for more videos like this. Thanks for watching. See you in the next one. Keep safe.